Okay, let's get practice 2, and then we'll do practice 3. So in practice 2, we're going to continue to take our scenario and clean it up and put it into a table. All right, so for scenario 2, we got this Homes. It's a popular construction company that builds affordable housing. When the company first started, they sold 1 home the first 3 months, and then 3 homes the second month, 9 homes the third, 27 homes the fourth. What we want to do here is kind of organize all that into our table. So this is a sequence. What we've been calling our first column, our domain, has been the term number, and then the term value. So what we've got here so far is the first 4 months. Now it's a sequence, so in each position, what's happening. So for the first month, they sold 1 home the first month, and the second month they sold 3. Third month they sold 9, and then the fourth month they sold 27, and then in the fifth, and then in the sixth. So as we're looking at a pattern that's happening here, what are we doing? 1 to 3 to 9 to 27. We are multiplying by 3. So it's increasing by a factor of 3. So 27 times 3 is going to give me 81. And 81 times 3 is 243. So by 6 months, they get 243 homes sold. Excuse me. Choking on some candy here. For Violet, okay, let's set up our table over here. Our term value. And then let's put that better. Okay. Violet, as a yoga instructor, he regularly posts new exercise videos on a website for her clients. 1 week after launching the website, she posted a total of 6. At the end of week 2, she posted a total of 10. At the end of week 3, she had a total of 14. And at the end of week 4, she had a total of 18. All right, so from here in our sequence, she posted 6 by week 1, okay? And then by week 2, she had 10. By week 3, she had 14. By week 4, she was at 18. So that's what we were given the problem. And then trying to figure out the combination of what's happening there for the pattern. So as I look at 6, 10, 14, 18, well, we're increasing by a plus 4. So plus 4, what is that? 22, and then 26. All right, I'm going to stretch it out here for Robin. All right, Robin is opening a restaurant and tells her staff that they have to go above and beyond to please their customers, especially on opening day. She reasons that if one customer is pleased with the restaurant, that person is likely to tell 4 people about it. Then each of those people is likely to tell 4 people about it, and so on. So this is similar to our family tree problem that we did in our notes. Okay, so as we go through here, we want to do kind of the same thing of organizing this into our table. So we're going to have our term number, our term value, okay? And we want to figure out by the time they get to 5th, 6th, and 7th tellings, where we are at in terms of the amount of people that know. Okay, so after the first telling, she reasons that likely 4 people are gonna then know, okay? And those 4 people will start telling 4 other people. So we got, let's see here, A, B, C, and D. Here's our 4 people. And if these 4 people go and tell, 4 other people, so let me give myself some room real quick, because that's not enough room. That was only if it was 2. Each of those 4 people tell 4 more people. So where are we going to be at? So this is the first one. Then the second one, as they would tell 4 people, I've got 4 here, 4 here, 4 here, 4 here. That's a grand total of 16. So we're at 16. And then if each of those 4 people start to tell 4 more people, then we really start adding up pretty darn quickly. And I don't have enough room for that. But as I can see, I went from 4 to 16, and then each of those people are going to tell 4 more. So what we are doing is multiplying by a factor of after a factor of 4. So 16 times 4 is 64. 64 times 4 is 256. 256 times 4 is 1024. 6 times 1024 times 4 is 4096. And 4096 times 4, 16,384 people. So that's a lot of people to tell after the 7th round of things, okay? Let's see. Then they also ask us to identify the appropriate function family and then describe whether the function is continuous or discrete. So we're stretching out here a little bit. Man, that thing is increasing pretty darn quick. And what's the type of graph that we've seen that's increasing very, very fast like that? These are the graphs that we've seen do that. These are what we call our exponential, okay? So this is the graph that's being modeled. This is part of the exponential family. And from there, because each telling can't be half of a telling, we're going to say that the domain, I should just say the function is considered to be discrete. Okay, so it's not continuous, it'd be more looking kind of like this. Okay. Now, how to rewrite that? Now, we've seen some exponential functions before, and we'll get into that. But this is what the exponential function looks like. In this case, because we're doing by a factor of 4, it's going to be 4 to the x.